Hello, myself Shubhashish Shah, Assistant Professor of Mathematics of Greater Kolkata College of Engineering and Management, GIS Group. In this video, I will discuss about binomial distribution. So, in my previous video, I have already discussed about distribution and distribution function of probability. I have given you some examples of random distribution function, but from now I will start discussion about special types of distribution, and the first type is binomial distribution. Binomial distribution. Okay. So what is binomial distribution? A random variable, a discrete random variable, capital X, is said to have a binomial distribution with parameters P, where P lies between 0 and 1, and N is a positive integer. If its distribution is given by like this 0, 1, 2 up to n, and f0, the probabilities are f2 ... up to fn, where the probability mass function will be given by probability of x equal to I is NCI p to the power I 1 minus p whole to the power n minus I. Okay. So this is the probability the distribution function is given of by this of binomial distribution, and binomial distribution is for only discrete variable. So x is a random discrete variable, and there are two parameters p and n. Now we have to know where binomial distribution, in which experiments, for which type of experiments binomial distribution are used. Okay. So first we have to know, suppose an experiment is repeated n times. Experiment is repeated n times, and we want some certain outcome. That is, we want to find the probability for some certain outcome. Okay. So if we repeat that experiment n times, and if we want that outcome I times, okay, I times, that is, if we get that outcome, that will be the success for us, otherwise we will be failed. Okay. So if out of n times I times we get the required outcome, then the probability of getting success I times out of n times is given by this distribution function, and in this type of experiments binomial distribution is used. So let us give an example. Suppose a coin is tossed 100 times. Okay, a coin is tossed 100 times, that is n equal to 100, and we want to find the probability of getting 53 times head, 53 times heads in 100 times toss. Then what will be the probability of getting 53 times heads if we toss the coin 100 times? This will be found out by using this distribution function, and it is under binomial distribution. Okay. So this was the definition of binomial distribution. Now we will find the mean and variance of binomial distribution, mean variance and standard deviation. Then we will go to some practical examples of binomial distribution. So now we will find the mean and variance of binomial distribution. So the statement is, if x has binomial distribution, with parameters n and p, then number 1, mean is np, and number 2, variance is npq. Okay, so and q is 1 minus p. So I missed to tell you that in the distribution function of binomial distribution, p has been used. P is the probability of success. P denotes the probability of success and q denotes the probability of failure. So obviously p plus q equal to 1. So in binomial distribution there are only two outcomes. Either it will be success or it will be failure. And p is the probability of success and q is the probability of failure. So p plus q is equal to 1. Okay. Now so first, to find mean, we know that the values of x are 0, 1, 2 up to n. Okay, and its probability distribution function is given by fi equal to probability of x equal to I is equal to nci p to the power I q to the power n minus I, or q is also denoted by 1 minus p. Okay, so mean or expectation is denoted by, you know that ex is equal to summation of I equal to 1 to n I, that is the values of x, into fi. Okay, so summation I equal to 1 to n I into fi, the value of the distribution function will put this n ci e to the power I q to the power n minus I. Okay, so now, okay, here I should be started from 0, but I have not written here 0, because if it is 0 then the whole value will be 0. So I have started I from 1. Now summation I equal to 1 to n I into nci can be written as n factorial by I factorial into n minus I factorial e to the power I q to the power n minus I. Okay, now I equal to 1 to n, summation I equal to 1 to n, this I and I factorial, by cancelling it will be I minus 1 factorial and n factorial, this is n factorial, and okay, I am taking out one n and one p outside the summation, then it will be n minus 1 factorial, and it will be p to the power I minus 1 and q to the power n minus I. Okay, and this is n minus I factorial. Just I have taken out np from the summation. Okay, now I equal to 1 to n, summation I equal to 1 to n. Next n minus 1 factorial by I minus 1 factorial. Now I am writing this n minus I as n minus 1 minus I minus 1 factorial. Okay, and this is p to the power I minus 1, and this n minus I is also I am writing this as n minus 1 minus I minus 1. Okay, now so np into summation I equal to 1, I am writing this as I minus 1 equal to 0 to n. And see this, if you think this n and this as I, ignore minus 1, this is n factorial by I factorial into n minus I factorial, that is similar as nci. So instead of n here it will be n minus 1, and instead of I here it will be I minus 1. So n minus 1 see I minus 1, p to the power I minus 1, q to the power n minus 1 minus I minus 1. Okay, this equal to np into, now this is the general form of ith term of binomial expansion of p plus q whole to the power n, right? Now the summation of all these terms, the summation of all these type of terms, it will be as written as p plus q whole to the power n minus 1, binomial expansion of this, and this is in the summation form, and we know that the value of p plus q is 1, so it will be np. Okay, so the mean of binomial distribution is np. Now I will find variance of binomial distribution. Okay, so we know that a variance of x, it has an expression like e to the expectation of e of x into x minus 1 minus m into m minus 1, where m is the mean which we have just found out, that is np. So we have to just find out e of x into x minus 1, then we will put these values here and get the variance of x. So e of x into x minus 1 will be I equal to 1. Okay, this will be 2 to n, because if you put, okay, first let me write I into I minus 1 into fi, where fi is the distribution function of binomial distribution. So I have started I from 2, because if you put 0 and 1 here, it will be 0. So I have started from 2. So now I am putting the value of the distribution function, which is nci p to the power I q to the power n minus I. Okay, so like before, I am just taking out here n into n minus 1 into p square from the summation. So what will be the changes inside? So I into I minus 1. Okay, so first if we split the formula of combination, then it will be n factorial, and n into n minus 1 has already been taken out, so it will be n minus 2 factorial by I factorial into n minus I factorial into p to the power I minus 2, because p square has been taken out, and q to the power n minus I. Okay, now n into n minus 1 into p square I equal to 2 to n, and this will be cancelled out, I into I minus 1. So this will be like n minus 2 factorial by I minus 2 factorial, and this n minus I can be written as n minus 2 minus I minus 2 factorial e to the power I minus 2, and this is also written as n minus 2 minus I minus 2. Okay. Now n into n minus 1 into p square. Now I am writing this as I minus 2 equal to 0 to n, and this can be written as n minus 2 c I minus 2. So if you think it n and this I, then n factorial by I factorial into n minus I factorial, that will be nci. So instead of n, here it is n minus 2, and instead of I, here it is I minus 2. So n minus 2 c I minus 2 e to the power I minus 2 and q to the power n minus 2 minus I minus 2. And this is the expansion of binomial expansion of the expression p plus q whole to the power n minus 2, and we know that the value of p plus q is 1. So this will be n into n minus 1 into p square. So this is expectation of x into x minus 1, which is n into n minus 1 into p square. Now we have to put this value here. So this will be n into n minus 1 into p square minus m is np minus 1. M is mean. So this will be n square p square minus np square minus n square p square plus np. So n square p square is cancelled out, and the remaining part is np into 1 minus p, where 1 minus p can be written as q. So this is our variance. So variance of binomial distribution is npq. Now standard deviation, we know that positive square root of where x, that is it will be positive square root of npq. So hence we saw that mean of binomial distribution is np, variance of binomial distribution is npq, and standard deviation of binomial distribution is plus root over npq. Now I will solve some problem of binomial distribution to make you understand better the application of binomial distribution. Okay. So let us take a simple example first. The question is the mean and standard deviation. The mean and standard deviation of a binomial distribution are respectively 4 and root over 8 by 3. 4 and root over 8 by 3. Question is find the values of n and p, hence find probability of x equal to 0. So this is a very simple problem of binomial distribution. I'll solve now. See that mean and standard deviation of this distribution has been given. and we know that mean of binomial distribution is NP. So NP here it is given that 4, and standard deviation, that is root over NPQ, is given as root over 8/3. So we have to find the values of N and P. So solving these two equations, we can find the values of N and P. So from here we can write that NPQ equal to 8/3. Yeah. NPQ equal to 8/3, and if we put the value of NP here, that is 4, then it will be 4Q equal to 8/3. Okay, so from this here we can write that Q equal to 8/12, that is 4 into 2, 4 into 2/3. So the value of Q is 2/3. If Q is 2/3, then P will be 1 minus Q, that is 1 minus 2/3, that is 1/3. And if we put the value of P in this equation, then we will get the value of N. So we are putting the value of P, N into 1/3 equal to 4, so N equal to 12. So the value of N is 12 and the value of Q is, the value of P is 1/3. Now we have to find the value of the probability of x equal to 0. So probability of x equal to 0. So since this is binomial distribution, x is a binomial variate, so a probability of x equal to 0 will be given by, we know that the distribution function is NCI p to the power I q to the power n minus I. Here n is 12, so 12, C, I is 0, P is 1/3, so 1/3 to the power 0, and Q is 2/3 to the power 12 minus 0. So 12C0 will be 1, 1/3 to the power 0, it will be 1. So the answer is 2/3 to the power 12. So probability of x equal to 0 is 2/3 to the power 12. Okay. So this was a very simple problem for binomial distribution. Now I will go to the second problem of binomial distribution. Okay. The next problem is okay. So the next problem, first write the question. It is observed that a cricket player becomes out within 10 runs in 3 out of 10 innings. In 3 out of 10 innings. Okay. If he played 4 innings, if he played 4 innings, what is the probability? What is the probability that he will become out twice? Number 1, out twice, and number 2, out at least once, within 10 runs, runs. Okay, so this is our question. First, read it carefully. I am reading it. It is observed that a cricket player becomes out within 10 runs in 3 out of 10 innings. So if an average score of a cricket player is given, that is, if a cricket player plays 10 innings, then in 3 innings he becomes out within 10 runs. So he becomes out within 10 runs. This is the event. Okay, so this is the event. This is an outcome. If he played 4 innings, what is the probability that he will become out twice, out at least once within 10 runs? So becoming out within 10 runs, it is our required outcome. That is, it is our success. So probability of to success, that is probability of becoming out twice in 2 innings out of 4 innings, we have to find, and we have to find the second question, that is out at least once out of 4 innings. So here he is playing total 4 innings, that is n equal to 4. N will not be 10. It is some students may think that n will be 10. No, n is not 10. This is the average score is given by this. Actually he is playing total 4 innings, it is given. Okay, so if n is 4, what will be p? P, that is probability of success, and here success is becoming out within 10 runs. So in 10 innings he always becomes out within 10 runs in 3 innings. So P will be 3 by 10. Then Q will be 1 minus 3 by 10, that is 7 by 10. Okay, now what are the required probability? What are our required probability? So number 1, question number 1, become out twice, that is probability of x equal to 2. You have to find it. And number 2 is out at least once, that is probability of x greater than equal to 1. Okay, at least once means he will out within 10 runs in at least 1 innings or more than 1 innings. Okay, so first probability of x equal to 2 will be NCI, that is 4C2 p to the power I. So 3 by 10 to the power 2 into q to the power, here q is 7 by 10, q to the power n minus I, that is 4 minus 2. Clear? Now this will be 4C2. 4C2 is 4 factorial by 2 factorial into 2 factorial, and 9 by 100 into 49 by 100. So if you calculate this, this will be 0.2646. So this is our required probability, 0.2646. Okay, now the second one, so probability of x greater than equal to 1 will be p of x equal to 1 plus p of x equal to 2 plus p of x equal to 3 plus p of x equal to 4. At most he is playing 4 innings. So you can find out these 4 probabilities and add this to get this, and alternatively you also can find in this way 1 minus probability of x less than 1, that is 1 minus probability of x equal to 0. So probability of x equal to 0 is already found out, 0.2646. So it will be 1 minus 0.2646 will be 0.7599. Okay, no, sorry, the 0.2646 is not the probability of x equal to 0. We have to find out this. Sorry, 1 minus NCI, that is 4C0 p p to the power, p is 3 by 10 to the power 0 into q, that is 7 by 10 to the power 4 minus 0, that is 4. So 1 minus, this is 1, this is 1, so 7 by 10 to the power 4, and this will be equal to 0.7599. Okay, so this is the required probability of the second question. Probability of out at least once within 10 runs. Okay, now I will give another example. So the second problem is A and B are two players are playing a game in which their chances of winning are in the ratio 3:2. We have to find A's chance of winning at least 3 games out of 5 games played. So chances of winning are in the ratio 3:2 means if total 5 games are played, then A wins in 3 games and B wins in 2 games. And actually they are playing 5 games, so we have to find out the probability of A's chance of winning at least 3 games. Okay, so here n is 5 because total 5 games are played, and P is equal to, P means probability of success, and here we are finding A's chance of winning. So if A wins, then it will be allowed as success. So the probability of A's chance of winning is 3 by 5 according to the ratio given. So Q will be 2 by 5, and required probability is probability of X at least 3 games, that is X greater than equal to 3. Okay, so we have to find out, you can find it in 2 ways. Either you can find out P of X equal to 3 plus P of X equal to 4 plus P of X equal to 5, or you can write this as probability of X less than 3, right, greater than equal to 3. If you subtract it from 1, it will be less than 3. That is 1 minus P of X equal to 0 plus P of X equal to 1 plus P of X equal to 2, right? So you have to find these 3 probabilities, and then you can get probability of X greater than equal to 3. Now, what is probability of X equal to 0? This will be 5C0 because n is 5. P to the power, P is 3 by 5 to the power 0 into 2 by 5 whole to the power 5 plus, for P of X equal to 1, it will be 5C1 3 by 5 to the power 1 into 2 by 5 to the power 5 minus 1, that is 4, plus 5C2 3 by 5 to the power 2 into 2 by 5 to the power 5 minus 2, 3. Okay, so 5C0 is 1, 3 by 5 to the power 0 is 1, and 2 by 5 to the power 5, it will be okay, I am not simplifying this, let it be remain like this. Okay, 5C1, what will be 5C1? 5C1 will be 5. 5C1 will be 5, and it will be 3 by 5 into 2 to the power 4 means 16 by 5 to the power 4. Okay, plus 5C2, that is 5 factorial by 2 factorial into 3 factorial, and 3 square, that is 9 by 5 square into 8 by 5 cube. So 1 minus 2 to the power 5, that is 32. 32 by 5 to the power 5 plus, okay, this is 3 into 5, 15, 5 into 3, 15 into 16 by 5 to the power 5 plus, okay, this will be 5 factorial and 3 factorial, it will be 20 by 2, that is 10. So 10 into 9, 90 into 8 by 5 to the power 5. Clear? So 1 minus, I am taking common 1 by 5 to the power 5. So it will be 32 plus 15 into 16. Okay, after calculating this, it will be 992, and this will be 2133 by 3125. So this is our required probability. So this was an example of binomial distribution. Now I will give you a problem. You will try it at home, and you have to practice this type of problems to understand binomial distribution. This is your home assignment. The overall percentage of failures in a certain examination is 40. What is the probability? What is the probability that out of a group of 6 candidates, at least 4 passed the examination. Okay, so I am dictating once. The overall percentage of failures in a certain examination is 40. What is the probability that out of a group of 6 candidates, at least 4 pass the examination? This is one, and I am giving another assignment. A family has 6 children. Find the probability that number 1, 3 boys and 3 girls, number 2, fewer boys than girls. So family has 6 children. You have to find the probability that in that family there will be 3 boys and 3 girls and fewer boys than girls. That is, for the second question, I can tell you fewer boys than girls means there are the possibilities are 1 boy, 5 girls, 2 boy, 4 girls. These two. Okay. If you take the another chances, there will be no fewer boys than girls. If you take 3 boys, 3 girls, this condition is not satisfied. 4 boys, 2 girls, no. 5 boys, 1 girls, no. And 6 boys. So in these cases, it will not be satisfied. So for the second question, you have to take these 2 cases. Okay. So try these 2 problems at home, and if you find any if you have any query, if you face any problem regarding this binomial distribution, you can contact with me, you can ask me. My contact details is given at the first slide of this video. Thank you.